Greetings, dear students. Welcome to Bachelor of Science third year program, Subject Botany, Semester 5, Course Code BOD 101, Course Title Plant Tissue Culture. Title of the unit, it belongs to Unit 4, Types of Cultures. Module name, Methods for Measurement of Growth of Cells in Suspension. This is Ms. Aditi Venkatesh Naik, Assistant Professor from Government College of Arts, Science and Commerce, Sakli, Goa. The outline of my module includes overview of suspension culture, methods for measurement of growth of cells in suspension culture. What students will learn from this, they'll be able to state the types of suspension cultures, describe the methods to measure growth of cells in suspension culture. What is a suspension culture? Suspension culture is nothing but culturing of cells or cell aggregates in liquid medium which is under continuous agitation. The cells here can be isolated either from in vivo plant material by means of mechanical or enzymatic digestion, or simply they can be induced from callus derived from the explants such as leaf, stem, pollen, anthers and so on. But the most common way to initiate any suspension culture is from callus which is already growing in the culture. Based on this, the suspension cultures are categorized into two major types, that is batch culture and continuous culture. A batch culture is nothing but a closed system where the suspension culture is formed in a fixed amount of nutrients, while in a continuous system, it is an open system where there is continuous supply of nutrient medium. The batch cultures are further categorized into four different types, that is slowly rotating culture, wherein single cell or cell aggregates are cultured into a specially designed nipple flask, shake cultures, which is considered to be a very simple and effective means of culturing cells, wherein a fixed volume of culture medium is placed into a conical flask mounted with the help of clips on a horizontal orbital shaker. The spinning culture, it is consisting of culture vessels which are approximately 10 liters volume and it is placed on a spinner at an angle of 45 degrees Celsius, and the stirred culture which is utilized for large scale production of suspension cultures, which is fitted with a magnetic stirrer and is having a sterile air bubble inside it. The continuous cultures are again broadly classified into two different types, that is chemostat and turbidostat. A chemostat is a culture vessel which could be a cylindrical or a circular culture vessel having inlets and outlet pores for aeration, introduction and removal of cells and medium. And here the liquid medium containing cells is stirred by a magnetic stirrer, and a steady state condition of density, growth rate, chemical composition and metabolic activity is maintained. Turbidostat is similar to that of a chemostat, but here the cells will increase due to steady state of growth, and because of which there is change in turbidity which is measured by changes in the optical density. And this culture system has an automatic monitoring system which adjusts the medium flow to maintain the optical density or to maintain the optimal pH. The growth of cells in suspension culture is said to follow a predictable pattern under appropriate conditions of light, temperature, aeration and nutrient medium. And this pattern of growth follows a different phases and is termed as a growth curve, which has different phases such as a log phase, a lag phase, a log phase, a linear phase, a decelerating phase, and a stationary phase. When we look at a lag phase is said to be a phase of growth wherein the cells start to prepare and divide and undertake all the necessary synthesis prior to cell division, which is followed by a very rapid cell division, causing a logarithmic increase in the cell numbers, which is referred to as the log phase or the logarithmic phase. A further period of rapid increase in cell numbers results in linear increase in number of cells, and there is reduction in cell division but increased cell expansion, and this is referred to as a linear phase, which is followed by a deceleration phase wherein there is decline in cell expansion and division. And finally, when the nutrients get depleted, some of the cells start to show cell senescence characteristics and the rate of cell division drops down and the growth curve forms a plateau which is referred to as a stationary stage of growth. Before we understand how to measure the growth in a suspension culture, we need to understand that it is very essential to test the cell viability because cell death may occur in suspension cultures due to several factors, and this is very important to test the viability of cells as the success of the culture is dependent on the cell viability. And there are various methods to test the cell viability, such as phase contrast microscopy, wherein the cytoplasmic streaming or presence of healthy nuclei in unstained cells is understood, the reduction of tetrasodium salts, fluorescent diacetate methods, Ivan blue staining, chalcophore white staining, and phenosafranin staining. Measurement of growth in suspension culture. For experimental studies on growth of suspension culture, cell density plays a very important factor. Cell growth will not be optimum at a very low or very high density of cells that can be used as an inoculum in the preparation of the cell suspension culture. Therefore, the cells are inoculated at an initial density of 2 into 10 raised to 6 cells per ml to 2 into 10 raised to 8 cells per ml, and this initial density of the inoculum that is used in preparation of suspension cultures may vary from plant species to plant species. And this initial density increases during growth and reaches its maximum density during the stationary phase of growth. Therefore, by comparing the cell numbers at the beginning of the culture and after certain days of incubation, the growth can be easily measured. The various methods that can be employed in order to measure the growth are cell counting, packed cell volume, that is PCV, cell fresh weight, CFW, and cell dry weight, that is CDW. Coming to the first method of cell measurement, that is cell counting. Here the cell aggregates that are present in suspension cultures are disrupted with the aid of acid or enzyme treatment, which is followed by centrifugation of the cells, and then the cell numbers are determined. In this methodology, we take 1 ml of the culture, that is 1 volume of the culture is added to 2 ml or 2 volumes of 5 to 15% chromic trioxide, or alternately it can be treated with pectinase enzyme. Further, this is heated at 70 degrees Celsius for 2 to 15 minutes, and heating is avoided if enzyme pectinase is used. This is then cooled and it is shaken vigorously for 10 minutes on a shaker. The contents are then centrifuged and the supernatant is discarded. After discarding the supernatant, the pellet is then resuspended in 0.8% saline, and further the cells are counted microscopically with the help of hemocytometer. The growth curve is expressed as cell numbers into 10 raised to 3 cells per ml of culture. In the packed cell volume, the cell suspension is centrifuged and the volume of the cell pallet is determined. Here, around 10 ml of suspension culture is aseptically harvested, which comprises of an uniformly dispersed suspension culture. The uniformly suspension culture is then centrifuged at 1000 RPMs for 15 minutes in a graduated centrifuge tube. Further, the supernatant is discarded and the volume that is occupied by the pallet in the centrifuge tube is determined. That is, the volume that is being occupied in the centrifuge tube is measured, and the PCV or biomass volume is expressed as ml pellet per ml culture. Next is determining the cell fresh weight, that is CFW. Here the cells are collected on a pre-weighed moist filter and they are washed and then weighed. Here we fit a pre-weighed moist nylon fabric filter into a filtration flask, which is a Hartley funnel under aseptic conditions. As you can see in the image, there is a Hartley funnel which has 4 plates, and into this a pre-weighed moist nylon filter is fitted, and then a known volume of cell suspension culture is added to it. The cells are then washed with sterile distilled water under vacuum in order to remove the moisture. After doing so, the nylon filter comprising of the cells, is then weighed in order to determine the fresh weight. The cell growth is determined as fresh weight per volume of culture. Similarly, the cell dry weight is also determined following a similar protocol that has been employed in cell dry weight. Here, the cells are collected on pre-weighed moist filter paper which is of nylon fabric. It is washed, dried, and again weighed. Here, drying is important because we wish to determine the cell dry weight. Here, a pre-weighed moist nylon fabric filter is fitted into a filtration flask aseptically. We filter a known volume of the cell suspension culture. Further, the cells are washed with sterile distilled water under vacuum to remove any moisture. Then the filter, along with the cells, is then dried in an oven for 12 hours at 60 degrees Celsius, and it is allowed to cool with the help of a desiccator containing the silica gel. The filter, along with the cells, is weighed and the dry weight is determined. The dry weight here is expressed as dry weight per volume of culture. To summarize, suspension cultures are nothing but cultures that comprise of single cells or cell aggregates which multiply or divide when agitated in a liquid medium, and it helps in understanding the growth and developmental processes. Growth of cultures is largely dependent on the viability of cells. Assessment of growth in suspension can be achieved by counting cells with the aid of hemocytometer, determining the packed cell volume, and estimating the fresh and dry weight of cells from suspension culture. These are the references that I have used. Thank you.